All right, we have another integral from Caltech Math Meet 2024. And this thing, it seems to be coming up a lot lately. We've been seeing a lot of natural logs and a lot of things. I don't really want to say what it is yet, but notice that we're adding within the integrals. And we also have this relationship where we've got something similar from here to here. And actually what it is, let's do this. Let me call this thing right here G. And so what you want to check a lot of times with integrals is like, just what is the derivative? Just take a derivative and see. And a lot of times that can reveal the answer. So if we just take a derivative on this, we get first 1 over natural log x, but then we need chain rule. Derivative of this is going to be 1 over x. So I can kind of write it like this. And then what we notice is we almost have the derivative right there. So what I'll do is, let's kind of make it happen. If I multiply in an x like this, then now I've created this G prime situation. I don't want to change it, of course. So to make it like we're just multiplying in 1, what if I don't really have space over there, so I'll write it over here. So I'm multiplying in x, so I just multiplied by 1. And then for this x, here, let me get some space, that's making a mess. So now for this x that I just created, we'll put a label on that one too. So that one, if f is x, if I take a derivative on that, the nice thing about that, it's just 1. So even though at first it's hard to see how the reverse product rule would work on it, if we just create a 1 right here, now we have f prime, and we have this whole thing set up where everything is in the form of the product rule, because the product rule, it's just if we have two things, f times g, and we take a derivative, it's f prime g plus f g prime. That's exactly what we have there. But we're looking at it as if our product rule situation's inside of an integral. And actually, so like this right side is like the integral, but it's equal to this thing. And when we have the derivative inside of an integral, the answer is just going to be f times g. So once you have it set up like this, you can basically go to the solution. Of course, we're going to have to evaluate at the end. This is a definite integral, but we know what our f and g is. We said f is x and g is this thing. So what we're going to have is just x times natural log x evaluated from e to e squared. I didn't try it, but sometimes a u sub can help here too, right? Because then you could maybe, I don't know, I guess if you did u equals ln x. I didn't try it, so I'm not sure. Don't quote me, but sometimes that, you don't really need it, but sometimes that can help make it easier to see how things work. So let me plug in here e squared. So it's going to be e squared ln, I'll just leave it and simplify it afterward. And then so then we'll plug in e and we get e ln e. Now this second one here, ln e, that's just 1. So what's going to happen is we end up with ln 1 or 0, and that's going to zero out this whole second part. So just get rid of that. Here, ln e squared, that's just going to be 2. To do it out, really, you would just do like log properties, bring the exponent in front. Ln e is 1. So then like that part cancels out and you're just left with a 2 there. So put all that together for my final solution, we just get e squared ln of 2, and that's it. All right, there you go. Good one today. Caltech Math Meet 2024. Thanks everyone for watching. Have a great day.